On June 14, 2006, a peculiar, long-duration gamma-ray burst was detected by the Niels-Gehrels-Swift Observatory that upended the then scientific consensus regarding GRBs. Known as the GRB 060614, the consensus had been that long GRBs were best explained by bursts of energy generated when a star collapses into a black hole, following a supernova event. Though today it's thought that it's possible that a star can, under certain very specific circumstances, collapse directly without a supernova. Correspondingly, it was thought that short-duration GRBs were due to neutron-star mergers. GRB 060614, however, didn't fit either explanation. It had attributes of both. There was no corresponding supernova, and the event showed almost all the hallmarks of a short gamma-ray burst, but lasted far too long. Located distantly at 1.6 billion light-years, this event led to a new class of GRB, known as a hybrid gamma-ray burst, and there remain a mystery as to what could cause them. After all, neutron-star mergers and supernovae are very different phenomena. Buried deeply in the literature, however, there is a rather unconventional hypothesis advanced that GRB 060614 was in fact a white hole. White holes are currently an entirely hypothetical concept, first advanced in 1964 by Igor Novikov, but largely developed by none other than Nikolai Kardashev. They essentially are a mathematical prediction brought about by a solution to Einstein's field equations. This does not necessarily mean they exist. It simply means that they are hidden in the math, and the laws of physics do not prevent their existence. That said, unlike a black hole where there is a known physical process to produce them, actually several, along with multiple detections of such objects, it remains somewhat unclear just how a white hole could be generated in nature. But there are some ideas, and it's very cutting-edge research. A big part of the problem is that white holes are at their most basic just a reversal of a black hole. In fundamental physics like that of Einstein, time doesn't really factor in. Rather, it works the same backwards and forwards. So a white hole is just a black hole in reverse. So if you could film a black hole's history and run it in reverse, it would be a white hole. But going backwards in time doesn't mean anti-gravity. Gravity works the same backward and forward in time. So unless something is falling into a black hole, it would generally be indistinguishable from a white hole, at least not under most circumstances. But the universe does not allow backwards movement in time so far as anyone can tell. But if you could get a collapsed black hole to somehow bounce back and reverse itself, it would become a white hole. Normally, this kind of a rebound shouldn't happen, according to the usual models of black holes. They are typically seen as singularities, points of infinite density in physics. But there's a wild card. We know that physics isn't complete. For example, Einstein's physics doesn't account for quantum effects, and the more insane the interior of a black hole gets, the extreme stretching and warping of space-time, the more evident quantum effects should become. They may end up being a major factor in truly understanding black holes. But a point of infinite density may not actually be what's going on here, a subject of much debate in physics. White holes, when looked at in the typical view of a singularity, would represent the exit point of a black hole. In this situation, the black hole and the white hole would be connected by a wormhole. This is really highly speculative, however, because past the event horizon of a black hole, our physics seems to break down, including seemingly that of Einstein, which is what's actually making the prediction here. A prediction of sorts in a framework where we know the physics is incomplete and breaks down is not an ideal situation. But maybe it's not actually breaking down. Work by Carlo Rovelli and colleagues suggests that it may not be, and that there isn't actually a singularity at the heart of a black hole in the classic sense. Instead, they envision that a black hole created in a stellar collapse is still just the original star, or what's left of it, veiled in its event horizon, warping space-time into a kind of tube or hole in space-time that continues to extend deeper and deeper as the black hole ages. The tube also contracts as it does this, Eventually, at some point, the tube should become almost a line, but it can't quite get there, and the whole thing ends somehow. But the main takeaway is that the singularity still exists, but it always lies in the future of the star falling into the hole, and it can't ever reach it. Thus, black holes aren't really singularities in the present, but represent them in the future. That may or may not be correct, but it does preserve the physics of Einstein. But it hammers home the point that what we don't know here is just what a black hole's singularity really is. Does it warp spacetime so severely that a wormhole can form, making the black hole a sort of impassable gateway to somewhere else? Or does it dig a finite hole in which it gets into quantum effects? More on that in a bit. This is very much unclear, but you wouldn't be able to traverse the black hole gateway under normal circumstances and end up somewhere else. You'd get spaghettified before you got there. And likewise, you can't get inside a white hole because it's the reverse effect. You don't get sucked in, you simply just can't ever enter it. But there's another mathematical oddity here, and that may be all it ever is, or maybe not. It has been advanced that if you could produce negative mass, you might therein find a way to survive a trip through a black hole, because as far as we can tell, it would be anti-gravity. But the problem with negative mass is that it's another mathematical trick. A reversal, like a white hole in a sense, but not exactly. You're just taking a number representing mass and putting a negative symbol in front of it. That's it. That does not mean it exists in nature, nor does it guarantee it could somehow be made. There are currently no ideas on just how to produce negative mass, but strangely, there is one possibility on the table. It's dark matter. This is based on the work of astrophysicist Jamie Farnes in 2017, and involves a concept called dark fluid. In a nutshell, the idea of dark fluid is an attempt to be tidy in a way, and explain both dark matter and dark energy as two sides of the same coin, or in this case, fluid, though fluid is a somewhat misapplied word here. You can think of it in this sense. On the scale of a galaxy, we see this phenomenon as dark matter. We see it as gravity holding galaxies together and keeping them from flying apart. But on enormous scales, such as the entire universe, we see it as behaving as dark energy and driving the expansion of the universe. This is naturally hard to rectify. How does something bend space-time as gravity on one scale, but expand space-time on a large scale as the expansion of the universe? Farnes, however, pointed out that it would work if the dark fluid had negative mass. What that might mean as far as traversing black holes is an open question, because we still wouldn't know exactly what dark fluid actually is, just that it represents negative mass in principle. A lot of unknowns there for sure, but within all of this there is a strange possibility. The Big Bang itself looks suspiciously like a white hole, at least from the physics we know. There have been a number of ideas in cosmology about the Big Bang really being a big bounce, and that it was a white hole of sorts. This type of cosmology is envisioned in several forms, cyclic cosmology, that instead of a singularity forming when a universe collapses, there is a point where no further density can be achieved, and the whole thing bounces, and a new incarnation of the universe occurs. In short, we may be inside the result of a class of white holes. But for that to work, you presumably need a method for the universe to collapse in on itself, and this is not well backed up by evidence regarding the expansion of the universe. But in the end, no one really knows how the universe will end. It's possible, however, that the same physics that allows for the Big Bang singularity to be a white hole also allows for a black hole to function the same way, that there is some maximum density that cannot be overcome, which might cause a similar bounce, and the eventual formation of a white hole. This maximum density state before a rebound of a star is known as a Planck star, the smallest possible area of space-time that you can cram material into. A white hole resulting from a black hole rebound would be a different class of white hole than the Big Bang if all of this is correct. Strangely, such a white hole would be indistinguishable from a black hole visually, but its properties would be the exact opposite. Unlike a black hole where once you enter the event horizon you can't ever get back out, with a white hole you cannot ever reach its event horizon. It's also been noted that white holes might actually be unstable, and thus do not exist for very long, due to a tendency to collapse back into a black hole. This might lead to a strange situation of cyclic black holes, but the reality is that we know so little about the interiors of black holes, and white holes have never been proven, and all of this is really just confined to Einstein's equation, which for most physicists appear to break down at the event horizon of a black hole. But if white holes do exist, that discovery will usher in an entirely new understanding of black holes and currently unknown physics. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently noticing that over the last few months, actually longer, a number of prominent YouTubers have been retiring or scaling back. I understand this to a degree. Some of these folks have really hefty production schedules to produce television level content that can cause burnout and contribute to a desire to take it easy, but it does not work that way for me. Science never stops advancing, and this channel and Event Horizon remain an absolute blast to do, and I'll never retire. And it's not only because I still enjoy it as much as I ever have, but the opossum is holding a taser. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.